NASA has officially announced the launch of their new mission to terraform the planet Mars. Terraforming is a term which literally means earth-shaping. It is the process of deliberately modifying the temperature, atmosphere, and surface topology of a planet to be similar to that of Earth's, in order to make it habitable by humans. One of the aims of the mission is to follow the water, which is essential for all life. Though there has been new research suggesting that ammonia or even methane could be used to sustain life also. However, ammonia and methane have much smaller temperature ranges and freezing points below zero, which would affect the kinetics of most biological reactions. Now to our science correspondent over in Trinity College Dublin for more.
Thanks, Aidan. As you all know, our essential resources, such as iron and silicon, are almost totally depleted, and Mars is an ideal candidate to extract. What? It's more feudal, and it's a waste of our resources. No terraforming!
No terraforming.
3, 2, 1, 0.
Ground control. Major Tom has landed. I repeat, the Major has landed. Initial analysis of surroundings is underway, and all signs to date show possibility for terraforming. Officer, keep an eye on the ship.
Atmospheric composition by weight: 95.32% CO2, 2.7% nitrogen, 0.13% molecular oxygen. Also detected is 1.6% argon, and there's 0.03% water vapor. Atmospheric pressure is currently reading in at 1 kilopascal. That's higher than the 35 pascal we expected, but still not the 1155 pascal we hoped for.
As I suspected, soil composition is 50% silica, 20% iron oxide, 10% magnesium oxide, 9% calcium, and 7.5% alumina. Soil is basaltic, as expected.
Actually, that loose rock material that covers Mars is referred to as regolith as opposed to soil. Soil is defined as having organic content, and there's no such content present here on Mars.
Whatever. It's freezing here. I thought it was supposed to be the summertime.
Temperature range expected was 184 to 242 Kelvin. This is a cold planet. Scale is currently reading in at 210 Kelvin. I mean, did you not read the briefing? I had like 100 pages in there on temperature ranges.
What am I, a scientist? I'm an engineer. What the? Do you speak English?
Yes, of course I do. Greetings, Earthlings. I am the Queen of all Martians. You may refer to me as the Martian Queen, and these are my humble yet beautiful male servants. But you can call me Queenie.
This isn't Planet of the Apes. I mean, isn't it obvious that they're...
What? You haven't heard of us?
Okay, we knew they were a primitive species, but they didn't even know we were here. What was the point of that Curiosity rover they sent over last summer? I even waved at it and everything.
They
know nothing about us. This is so insulting.
We do too know about you.
Oh, really? Earth, 135 to minus 90 degrees Celsius. Approximately 70% of the surface is covered in water.
How luxurious!
8.7 million eukaryotic species inhabit this filthy planet. Most of those reside in the most vile conditions. With so much uninhabited space on this filthy planet, why would you even come here?
Nearly 50% of all your planet species reside in the oceans, but 90% of those species stay within 200 meters of the surface.
Your planet's atmosphere has the extraordinary power to absorb the sun's UVB and UVC rays, and yet you destroy it with your beloved CFCs. Do you know what I do for some oxygen allotrope?
You only have a tiny concentration of it to begin with, and yet you reduce its half-life to a mere 3.5 minutes with the production of nitric oxide.
Despite your species' disdain for your own planet, there still resides life in almost every region, despite what you humans call extreme conditions.
Some of your planet's species live in deep ocean brine pools, away from sunlight and saturated with salt. Methane and bacteria thrive using chemosynthesis.
What's chemosynthesis?
Even in the hydrothermal vents deep out near seas, where creatures experience extremely high pressures and temperatures as high as 673 Kelvin, you vaporize instantaneously. Not only that, but it's basically like living in an acid. These minute creatures are more capable than your entire race.
Wow. That was pretty impressive. And insulting. To be honest, we didn't even know if this planet could sustain life. Excuse our ignorance.
We wouldn't expect anything less from carbon-based life forms. We silicon-based life forms are superior in every way.
Ha ha ha! Excuse me, but carbon is the 4th most abundant element in the solar system, and it's 10 times more abundant than silicon. Radio astronomers from our planet have discovered over 80 different molecular compounds in interstellar space, over 70 of which contain carbon.
You're forgetting that silicon shares many chemical properties to carbon, can form similar chemical structures and bonds, and it has a valence of 4.
But silicon-based life forms require such high energies to be formed. Plus, the single carbon-carbon bond is twice as strong as the silicon-silicon bond, and carbon can form double bonds with oxygen, giving it the ability to form CO2. That's a major constituent of your atmosphere and of ours. Plus, through respiration, carbon dioxide can be easily removed from the body. Silicon dioxide, however, with a higher melting point, means it's harder to dispose of. Whoa, I feel pretty dizzy. What's wrong with me?
I'm fine.
Foolish earthlings! They do not realize that our climate is not suited for them at all. Look at our heavy breathing. Our atmosphere is far different to yours, both in structure and composition.
It weighs just 25 teratons, which is so much less than Earth's 5,148 teratons. Yet its height is 11 kilometers, which is 4 kilometers greater than yours. This is why our atmospheric pressure is so much less. It's a pity, really. If we'd had a slightly denser atmosphere, we would share a similar climate to on Earth. Wouldn't that be handy? Damn escape velocity.
And as I'm sure you're aware, human respiration is a series of what you Earthlings call redox reactions. The balance of these reactions depends on the rate constant, and the rate constant depends on the pressure of your environment. In the reduced pressure of our atmosphere, you simply cannot breathe. Foolish Earthlings. They're just lucky they're not staying here for longer. Imagine if they were here for the CO2 release. That's in a couple of months, isn't it? I mean, if they can't handle a once-off change, what would they be like during the 25% change we experience every year?
Wait, I thought that was happening fairly soon. Have you been watching too much Earth Time TV again? A year here is 687 days, which means it's summer now, not winter.
Oh, right, yeah. I just really like the Kardashians.
Major, I think we should leave. We're simply nowhere near ready to form any type of terraforming here.
Nonsense. We need to harvest and exploit all of their resources. You've forgotten the main objective of this operation. We've got to harvest this place for all that it's worth. We're going to dig up the gold, and I'm going to be rich.
Firstly, there isn't any substantial amount of gold here.
Fine then. I don't need any gold. We'll just harvest and exploit. We're going to just harvest and exploit the entire planet. First, I'm going to dominate the whole planet and raise the surface temperature by at least 60 Kelvin to make it comfortable for all humans to live. This will melt a huge amount of ice at the poles and beneath the surface. This could be achieved by reducing the surface albedo. We can spread dark, heat-absorbing dust grains all over the polar ice caps.
Or we could introduce bioengineered plants to reduce the planet's surface albedo.
Or we could just pump the place full of CO2 instead. I mean, all the carbon dioxide in the soil.
It's regolith, but even still.
Whatever. With all of that and the CO2 at the poles, the pressure would be increased by 500 millibars, enough for all of the ice to melt.
Even better, strong greenhouse gases such as ammonia and methane can be mined from the Jovian planets such as Jupiter and Saturn.
That technology is far beyond anything we have at this moment in time.
Fine then, we need to change the chemical composition of the atmosphere. We'll need lots of nitrogen, oxygen, ozone, and water. The Sabatier reaction can be used to convert the plentiful CO2 on this planet into the water and methane fuel that we need.
Let me do the calculations. We'll need to increase the pressure by at least a factor of 100.
Plus, they say they're silicon-based life forms. Think of how many Intel chips I could make from one of their bodies.
What? Stop! Just wait a minute. Major, I've decided you're right. The mission is our priority. I've managed to talk to the aliens, and their mysterious cosmic abilities, they've managed to make the atmosphere of Mars safe for us humans. It is now safe for you alone to take off your helmet.
Really? Everything? Even the soil?
Well, that's still regulated. But yes, everything else.
Well, okay then.
Idiot.
This is NASA Control. What's going on up there? Is it possible to terraform Mars?
I'm sorry, sir, but there's just no chance of terraforming. The minimum requirements are simply not met. There's too many objectives we've filled, and currently we don't have the resources to carry them out.
Yes! Greetings, Earthlings! I am the Queen of all Martians. You may refer to me as the Martian Queen.
Oh, never mind him. Or her. I'm not really sure. But anyway, there's no chance we can terraform Mars. Even if we were to release all the CO2 in the poles and in the ice caps, it still wouldn't be enough to increase the temperature above the freezing point of water.
Yes, even if you were to initiate some kind of carbon dioxide runaway process, our atmosphere would still be lethal to all you humans. And that's before you account for the yearly changes in CO2.
And for any substantial atmosphere to be kept in place, it would be necessary to increase the mass of Mars and shift its orbit closer to the Sun by approximately 15 to 20 million miles. The only way for us to increase the mass would be bombarded with asteroids and maybe a couple of Jupiter's moons. And if that was hit at the right place, speed, and angle, that could possibly shift Mars' orbit closer to the Sun. That's if the planet could withstand the impacts in the first place. Honestly, I can't see this happening. And even if it did, I just can't see that happening at all, sir.
Also, the current surface gravity on Mars is just 38% of what it is on Earth. We're not even sure yet if that's enough to avoid problems associated with weightlessness, such as space adaptation syndrome, muscular atrophy, and reduced production of red blood cells.
And I can't see the gravity changing anytime soon around here. Even enough just to reduce the escape velocity and have some build-up in atmospheric pressure. Even if it did, this planet is geologically dead. There is no liquid iron core here like on Earth, meaning there simply isn't a magnetic field here.
Whoa, 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 that's too far. You can't call our planet dead. What's that about? But she does have a point, I suppose. It means those frequent solar storms that you Earthlings are protected from wreak havoc here on Mars.
Our species is well adapted to the warm UV flux here on this planet, but it is my understanding that only a small percentage of you humans enjoy such radiation.
Also, there's currently no water readily accessible here. I think your best bet would be somewhere like Europa. That should be enough for about an ocean.
And by the time you're done crashing cosmic bodies into our planet, who knows if there'll be any of our home even left?
They have a point. I mean, we can't even terraform 90% of Earth. What makes you think that Mars is going to be an option? Honestly, we should focus our resources at home instead and look into biodiesel. I'm attached. Oh, sorry.
Thanks. Yeah, they're both working. I'm going to open the floor now to questions from the judges. I'm sure they have one or two.
Why does the carbon dioxide change as much as 25% on the planet? What drives that?
Between the summer and the winter months, the carbon dioxide, the temperature changes in Mars are so great that the carbon dioxide in the atmosphere will freeze and form the ice caps. And it's 25% of carbon dioxide that's in your atmosphere will freeze and form the dry ice that decomposes. And then once that turns around and it's near the sun again, that will melt, release the 25% back into it.
Oh, me. So what do you think is the biggest reason why they shouldn't go ahead then with terraforming? Is it because it wouldn't be possible to do it, or because you have too much sympathy with the blue Martian queen? You did kind of murder your mater, though.
So just to be clear, so the practical considerations of terraforming are the reason why you wouldn't do it. Is that what you're saying? So it's just economics then, is it? Or is the science of it incorrect?
Well, the science is not exactly. It's not there is science behind it, but I mean, yeah, it's economically, yeah, more economic than anything else. That said, Mars, Mars is very hot. Yeah, something closer to the sun with liquid iron core, liquid atmosphere, cold in the atmosphere.
You're also looking at hugely different kinetics in your chemistry reactions, like your pressure's gone, rate constant, completely different. And the temperature, yeah. Like, we're not even unit enough. No, it's not going to be us.
The pressure is so low there, like, obviously your head actually wouldn't explode, but all of your slime will fall off. Yeah. Yeah, I suppose, certainly the maybe
You mentioned the rover there. How much of the, like, given that these are early days of space exploration, I suppose, how much of your chemistry degree will be redundant and, be proven to be wrong in about 20 years' time, do you think?
I think chemistry is under constant change, and you're constantly seeing more and more technologies developed and more drugs and more synthesis. So I think part of being a chemist now is being able to adapt to these changes and learn as you go on. Provided, I think we've been brought up in an age where we are kind of used to learning. Like, if you think back when we were smaller, we didn't have computers again, like half our rooms are Mac, the other half are PCs, and their laptop. So I think we're the generation that are really used to continuously being changed, and I think that's going to stand to us as chemists when we take in the new and know the old and then merge them together.
Great answer. So basically, don't learn by rote, understand.
Is a really bad idea. You're not to screw you over in the exams.
I'll stop there. That's perfect.
You made a statement that Mars was geologically dead. Have they done enough studies to make a statement as strong as that?
Well, we probably use a little bit of oil.
I think the lack of samples also shows you the difficulty in terraforming. We can't even get back a couple of samples. What is the probability of those being able to get humans there to survive? Currently, we definitely don't have enough information on any aspect of Mars to continue it on. There's some new missions that are continuously looking there.
You could be right about it, like, yes, so it could be right. We kind of, like, most of you do geology anyway.
Do you want me to weigh in? Yes, no, it's fine. I mean, you kind of touched on it in your answer, yeah. In terms of the Earth's geological system, Mars is dead. It doesn't have plate tectonics. Now, the reason we know that, we don't need samples to know that, because we can just look at the surface bombardment of Mars, and we can look at features that are ridiculously ancient, so we know that there's nothing been moving for a good long while. And the samples, you made a very good point as well, the samples that we have from Mars, Shergottites, they come to Earth as meteorites, so we're not collecting them. So we're basically working off scraps when it comes to that sort of thing. But the interesting thing about Martian geology is that you can actually use it to understand Earth geology, because you can see structures there on Mars that you can't see on Earth because of plate tectonics and because of vegetation. So it's actually a really interesting place geologically. Just to set that all straight. But very, very interesting interpretation.
Okay. What I'm going to do now is I'm going to open the floor to any questions. If any of the school children or other senior fresh have any questions, stick your hand up and we'll run and get you a microphone. Anybody? They did that good a job answering your questions, did they? Oh, no, he's scratching his head.
Come on, don't be shy, ask a question.
Anybody
There's
have
no
a
such
question?
thing as a
Oh, here we go.
My question is, why would you try to terraform Mars in the first place? Yeah, it just seems like a kind of stupid idea.
Well, obviously at the current state in time, Earth is fairly okay. We can all go back outside and breathe the air, but the hypothetical reason that we'd have to terraform Mars would be if the planet was ruined by, say, global warming, or I don't know, some kind of other terrible disaster. So it's worth looking into. I mean, there's a number of people who do look into it regularly, and then there's other people, Buzz Aldrin is counted amongst them, that just kind of want to push the frontiers of humanity far beyond Earth to Mars is kind of the next frontier. It's the closest one that we can go to. You're right. I mean, it's not necessarily the most practical thing in the world to do or to spend money on, but
it's also to do with, do you remember in the very start, the news report, and we said that Earth's natural resources were running low? Were that to happen and we were to, like, humanity could destroy Earth itself. There could be a nuclear explosion that means everyone has to leave. Then we're looking at Mars. Then we're looking at the next safest place. Realistically, if it was to do with something like when the sun explodes in a couple of billion years, Mars is a really bad option because it's too close. But if it was that, I don't know, there's some nuclear war, nuclear disaster, and we bomb it. Yeah, just depleting it. Like, even just we use up everything that we needed and we don't have it anymore.
Silicon, you heard of silicon and iron, as you know, 50%, 20%. So, yeah. Answer the question.
Right, we'll go one final question and then we'll go to the next group.
What's an albedo?
It's the like reflectivity of the Martian surface or any surface of the planet. Tune.
Oh, no. Yeah, it is just albedo. I don't know. We've never heard the word before. It was an interesting concept. It is how well a planet reflects sunlight or absorbs sunlight back into space. And obviously, something like the poles, even on Earth, reflect a lot of sunlight.
So basically by changing it, you can change how much heat the planet's going to absorb. The more heat the planet absorbs means the easier it's going to melt the ice. So if you can reduce the albedo, you'll make the ice melt faster with the same amount of sunlight.